Hey, this is Dan from Abbott University, and today I'm going to show you the table method for graphing parabolas when you have an equation in vertex form. Now here's an example of an equation in vertex form, and just to be very clear, what do I mean by vertex form? I mean that the equation is written thusly. We have a times the quantity of x minus h squared plus k. And the reason why they call it the vertex form is because it's very easy to know what the vertex is when the equation is written in this particular form. The vertex will always be the point hk. So what is h? H is the number being subtracted from x in this moment. What is k? K is the number being added to this term in this moment. Now this equation right here, our example, is indeed in vertex form, although it might not totally look like it. But the reason why it is because first of all, the y is isolated on one side of the equal sign, just like this is. We do have an a, even though it's not showing. It's the invisible 1 that's being multiplied to this quantity, so the a's correspond in that way. We have an h. Our h happens to be 3. 3 is the number that is being subtracted from x right now. And we actually do have a k also. It is the invisible 0 that's being added at the tail end of this equation. So keeping that in mind. So that is certainly enough information to find the vertex. The vertex of our equation is therefore 3, 0. Okay. So I'm going to go ahead and just plot that point right now. Okay, so that would be somewhere around here. So that means that we have a parabola that is opening upward in this direction, where it swoops down and lightly grazes the x-axis and goes up like that. Now I know that it swoops upward or opens upward because the a is positive. I did not mention that before, but if the a happens to be negative, then we would indeed have a downward facing parabola like that. But our a is positive because it is a positive 1 that's secretly hiding in front of that quantity right there. Okay, good. So we found the vertex. Now really, whenever you're doing any method of graphing parabolas, finding the vertex right off the bat, that's a pretty good place to start. I'm just going to tell you right now. And using the table method, it's definitely a good place to start. So basically the table method is when you form this 2-column table of x values and their corresponding y values. Now here's the way that I like to do the table method. First, I like to find the vertex, and when I find the vertex, what I'm going to do then is I'm going to write that vertex here. Now notice how I'm not writing the vertex up here. I'm putting the vertex kind of down a little bit. And the reason for that is I'm going to investigate 2 different points above it, and then I'm going to investigate 2 different points below. Okay? Now, when I'm investigating 2 other points that are on this graph, what I like to do is, first of all, I like to investigate easy numbers. So what I mean by that is I'm going to do 1 here and 0 here. So you can always lead with x values in a sense. So let's go ahead and investigate what happens in this equation when x equals 1 and what happens in this equation when x equals 0. Now I'm purposefully choosing 1 and 0 as x values to investigate because these are really easy numbers to plug into this equation. And here's what I mean by that. Let's plug 0 in first. When x is 0, y equals 9. That was a very easy calculation because 0 minus 3 is negative 3, negative 3 squared is just 9. That's why I choose 0 as an x value to work with. So therefore we would have a 9 here. And what happens when x is 1? Let's investigate. Well, we would have y equals 1 minus 3 squared. Now I find that 1 is a fairly easy number to work with as well. So that would be y equals negative 2 squared, which ends up being y equals 4. Okay, so that means that when x is 1 in this particular equation, y is equal to 4. Good. All right. Now, here is what we have so far. We have our 3, 0 graphed right here. Now, we know that that's the vertex. So we know basically we're going to have a parabola that looks something like this. I've already done 2 points to the left of that vertex. All right. Now, what are those points? It's 1, 4, which is like right here. And we also have 0, 9, which is extend that a little bit. That 0, 9 is right there. And I can definitely connect the dots at this point. So the dots would be like this. Alright, now this 1, 4 is in the way, but you get the idea. So we know that the rest of the parabola is going to open up in this direction. Now here's the good news. The good news is that there is indeed this invisible dotted line, axis of symmetry, that cuts straight down through the vertex. And when they say axis of symmetry, that basically means that everything that happens on the left side is going to be reflected on the right side, and vice versa. Okay? Now, how does that translate when we're using this table method? The way that that translates is, what I could do is I could notice that, how did I get from 3 to 1? I subtracted 2. So from 3, I got to 1 by going 3 minus 2 equals 1. So what I'm going to do is go 3 plus 2 to get 5. Okay? And then, how did I get from 3 to 0? I subtracted 3. So what I'm going to do is, instead of subtracting 3, I'm going to add 3. So 3 plus 3 is 6. Okay? Now, what have I done? I'm basically starting to consider other points over here that correspond with the x value of 5 and the x value of 6. Now, since I kept the distance between 3 and 5 as the same as the distance between 3 and 1, it creates the scenario where the y value here corresponds perfectly with this y value. And the y value here corresponds perfectly with this y value. Now that is why I always put the vertex in the middle, because then all I have to do is investigate 2 other x values, hopefully x values that are easy to work with, find out what their corresponding y values are, and then I find 2 other x values below, or in a sense to the right of the vertex, and I make sure that these y values are the same distance, these x values are the same distance away from 3 as these x values are. And by that I mean the absolute value distance between 3 and 5 is the same as the absolute value distance between 3 and 1. The absolute value distance between 3 and 6 is the same as the absolute value distance of 3 and 0. And since that's the case, and since we have the axis of symmetry and everything's being reflected, it's going to cause the exact same y values, namely 4 and 9 in this case. So all I have to do now is plot those points. I now have 5, 4, which would be right around here. And I now have 6, 9, which would be right around here. And all I have to do from that point forward is connect the dots. And that is a relatively accurate parabola. Not bad for hand drawn, even though it looks a little bit like a V. The fact that the points and the coordinates of the points are represented make it an accurate parabola. So that's how to use the table method.